Hello everyone, my name is Daryl. I work as a software developer, and in this video you'll see how I naturally work through a LeetCode challenge. This is a problem that I'm seeing for the first time, and I'll explain it myself as I work through it. My solution won't likely be the best or the most efficient. It'll just be the one that I come up with first. I'll try to not make it too horribly inefficient, but we'll see how that goes. So I do these challenges in Kotlin, and I'm going to be using IntelliJ to go ahead and create my code instead of the browser, just because you get a lot of IntelliSense and I can test it more easily in here. So this one is rated as easy, and it's number 26, remove duplicates from sorted array. So give an integer array, nums sorted in non-decreasing order. Remove the duplicates in place such that each unique element appears only once. The relative order of the elements should be kept the same. Since it's impossible to change the length of an array in some languages, you must instead have the result be placed in the first part of the array, nums. More formally, if there are k elements after removing the duplicates, then the first k elements of nums should hold the final result. It does not matter what you leave beyond the first k elements. Return k after placing the final result in the first k slots of nums. Do not allocate extra space for another array. You must do this by modifying the input array in place with O1 extra memory. Custom judge. The judge will test your solution with the following code. Okay. So then I just show an example here. So the input is this array, and we are outputting. You output a 2 and then the array. Your function should return k equals 2 with the first two elements of nums being 1 and 2 respectively. So the function just returns the length, I guess is what it's saying. Okay. Does not matter what you leave beyond the return k. Let's say your underscores. Okay. So this one doesn't really seem too bad. So let's go ahead and copy this function over to our solution here. Okay. So what we can do, so they very specifically said that they don't want us to create another array. Okay, no, this should be easy. So we're just gonna create current val is gonna be an int. I'll just set it for 0 for now. Actually, what's the range on the inputs? That's the length. The values. Okay, so let's just set this to -1000. And I'm just doing that because that is below the bottom edge here of -100. It won't really matter anyways. It's just a placeholder value. So then we're going to say for num in nums. Let's actually change this really quick to also have the index because that's going to be important. So there you go. So current val is equal to value. Then we know that it's a duplicate. That's kind of how we're going to do this. So then we're going to also need to hold on to we're going to call it current write index, and we'll start that at 0. We just need to do that because of how they want us to do the problem, because we can't simply remove. Well, they don't want us to remove like the record or anything like that, or the value with the index. So we need to have our own write index, which is different from the index that we're actually iterating over. So first it'll start at 0. Okay. So if it's a duplicate, then we want to continue. How about that? Just go on to the next one. If it's not a duplicate, then will be here. And then what we want to do is nums.set right index value, and it wants to change it to indexing. Okay. Then current right index plus plus. I change it to var, and this is going to be var as well. Current val is equal to value. At the end, return current right index plus 1. Now I'm going to go ahead and just quickly throw this into here and see if it gets a pass or if I get a fail. Okay, it failed. Input was 112. My output was 122, which is technically what I intended. It expected 12. Doesn't, like, this would be the correct one. Interesting. So I was off by 1 with the index. Okay. Let's go ahead and do a submit and see if we fail any of the tests. All right, we passed. That was pretty easy. So just to really quickly go over that code, and it looks like it's pretty good too, as far as the memory goes. It's even above 50%. It's a pretty simple solution. So to quickly go over the code, we're getting this nums, it's an int array. We're creating this current right index, and this current right index is going to be our value for where we're writing to, which is going to be different. And actually, as far as efficiency goes, I never actually end up using the index. That's because I changed the way that I was going to do this problem after I wrote the for loop. So that could be removed since it's not being used. But anyways, this index is what we're actually using to write to the array. This is our current value. This is the value that we compare to see if the new value is the same as the previous one. Then we're looping through nums. So like I said, you don't need the index. So if we go to the next value and it is exactly the same value as the previous one, which this will be set here the previous time. So like let's say we're going through the first time. Obviously this is not going to equal -1000 because it's outside of the range of the values. So then we're going to go down here. And technically this line right here, in this case for our first example, we're not doing anything. It's just setting the same value to the same index of the array. Then we're increasing that index. So we're going to go to 1. And we're setting the current value to value. So if this value was 1, now current value is 1. So if we go to the next index and it's also 1, this check is going to be true. And if this check is true, what we want to do is continue. It's going to go to the next iteration of the loop, and it's not going to do any of this stuff because it's a duplicate. Now notice that when we do this, our current right index is still going to be 1. So when we go to the next value and it's a 2, we're going to be writing that to the second value instead of the third, which this index would actually be. And this works because they don't care about any of the values after the range. And at the end, correcting this to the actual correct answer, we're just returning the current right index that we were at. And the reason that this would be the correct instead of adding 1 at the end like I did initially is because we're doing this add to the right index at the end of the for loop. So it's ready for the next one. So we don't have to add the one manually. All right, thanks for watching. I hope this helped one of you guys. See you guys later.